torque. Torque. Last time we studied a moment of inertia. Now we study torque. If a pivoted, hinged, or suspended body tend to rotate under the action of a force, it is said to be acted upon by a torque, or turning effect of a force about axis of rotation is called the moment of force. Yeah, torque due to a force. Example, this is the door. Here we take a apply force perpendicular the plane of this door. Then door rotate about this axis. Okay. Suppose here we act a force F in this direction. Then this wheel is rotate about in this direction. Or on a particle, so if a particle rotating in XY plane about the origin under the effect of force, this is the particle, position vector of the particle is R, force acting on this direction. Now we take two components. This is the phi. Angle between the R and the force is phi. So now take this direction, we take F cos phi, and perpendicular component is F sin phi. Then torque equal to R cross F means RF sin theta. About this origin. If origin a reference point is different, torque is also different. Now, important point. Torque is an axial vector. Is that its direction is always perpendicular to the plane containing vector R and F in accordance with right-hand screw rule. For a given figure, the sense of rotation is anti-clockwise, so the direction of torque is perpendicular to the plane outward through the axis of rotation. Okay. Rectangular component of force. So F radial component F cos theta, and transverse component F phi means F sin phi, transverse component of force. So torque equal to RF sin phi. So F sin phi is transverse component. So means torque equal to position vector into transverse component of the force. Means the magnitude of torque is given by the product of transverse component of force and its perpendicular distance from the axis of rotation. Here R is always we take a perpendicular distance. Okay. Torque is due to the transverse component of force only, not a radial component. Radial component give a linear motion, and transverse component give a rotational motion. Torque equal to RF sin theta means F into R sin phi. So F R sin phi means D. So D means RD sin phi. In figure, this is the perpendicular. D means opposite side. So means phi ki opposite side. D means R sin phi. Perpendicular distance from the origin of force acting line. Okay. So here torque is equal to right force into perpendicular distance of the line of action of force from the axis of rotation. Means Torque is also called the moment of force, and D is called the moment or lever arm. Okay. So means torque equal to RF, R cross F means RF sine theta. So torque maximum, where maximum? When the sine phi is maximum, is equal to 1, is delta phi equal to 90. F and R is perpendicular to each other, then torque is maximum. Torque is 0. So sine phi minimum is equal to 0, is that 0, yeah, 180. Means torque F is collinear to R, parallel, yeah, anti-parallel. Next, for a given force and angle, the magnitude of torque depend on R. The more is the value of R, the more will be the torque and easier to rotate the body. Give an example. First, handle are provided near the free edge of the plank of the door. तो door का handle free end के पास ही होता है, not a rotational axis. If handle is near to rotational axis, then door को open और close करने के लिए हमें force ज्यादा देना पड़ता है. Second, the handle of screwdriver is taken thick. Third, in village, handle of floor mill is placed near the circumference. तो फ्लोर मिल है, उसमें भी जो हैंडल दिया गया होता है वो सर्कमफ्रेंस पर दिया गया होता है. The handle of head pump also kept long. The arm of wrench used to opening the tap is kept long. Okay, तो ये सब एग्जाम्पल है. R रोटेशनल एक्सिस से पोजीशन वेक्टर जितना बड़ा होता है उतना टॉर्क बड़ा होता है, इजीली हम रोटेशन कर सकते हैं. यूनिट इज न्यूटन इंटू मीटर और सीजीएस यूनिट इज 10 इंटू सेंटीमीटर. डायमेंशनल फॉर्मूला वी राइट m1 l2 t minus 2. न्यूटन इंटू मीटर मीन्स जूल. Its dimension formula. If a body is act upon more than one force, then the torque is the vector sum of each torque. The means torque equal to tau 1 plus tau 2 plus tau 3 plus up to so on. Next, a body is said to be in rotational equilibrium if resultant torque acting on it is 0. Is that summation tau equal to 0. Translational equilibrium means summation f equal to 0. And rotational equilibrium means summation tau is equal to 0. ये दोनों f और tau इक्विलिब्रियम में होता है, तो रोटेशनल इक्विलिब्रियम है और ट्रांसलेशनल इक्विलिब्रियम है. तो इन मैकेनिक्स बॉडी इज इन इक्विलिब्रियम. ओके, ये भी हमें याद रखना है. In case of a beam balance or a seesaw, the system will be rotational equilibrium. So in a garden, we seesaw or a beam balance means one person place here, one person place here. Then this is the equilibrium, means no torque acting on this system. Tau 1 plus tau 2 equal to 0. Tau 1 equal to R cross F. This is the origin. R means L1 cross F1, but angle between them is 90. So sin 90 L1 to F1 L1 minus. In this direction torque is here take positive, and here R cross in this direction torque is negative. So L cross LF sin 90, so F2 L2 minus. So anti-clockwise take positive, clockwise take negative. Means F1 L1 is F2 L2. However, if tau 1 greater than tau 2, then left hand side will move downward, and if tau1 less than tau2. If right hand side will move downward, the system will not be in a rotational equilibrium. So F1 is equal to L1 is equal to F2 L2. This is the rotational equilibrium. Means here we find F1, yeah, F2 in this equation, L2 by L1 also right. On tilting, a body will restore its initial position due to a torque of a weight about the point O till the line of action of a weight passing through its base on tilting. The body will propel due to torque of weight about O if the line of action of a weight does not pass through the base. Now here in a tilting यहाँ पर है ड्यू टू वेट हम यहाँ पर कोई बॉक्स को कोई एज पर खड़ा रख के सपोज इन दिस डायरेक्शन में रोटेशन करते हैं, लेकिन उसकी वेट की वजह से वो इस डायरेक्शन में नहीं आता क्योंकि इस डायरेक्शन में टॉर्क लगता है. तो मीन्स सेंटर ऑफ this is the G, center of gravity. This is the R. Now torque and tilt दोनों one side होता है तो वो गिर जाता है, तो in this direction में वो आता है. तो weight does not pass through the base. तो weight base, this is the base है. base में से weight की action of line base में से pass होती है. तो torque act oppose the tilting. बट बेस में से नहीं, यहां से पास होती है साइड में से, तो टॉर्क एक्टिंग इन द डायरेक्शन ऑफ द टिल्टिंग. नाउ कंपेयर रोटेशनल एंड ट्रांसलेशन मोशन. तो हियर F is equal to ma in a translation या linear motion. F now rotational motion we take torque, angular force, mass. Rotational motion में moment of inertia a, here we take angular acceleration. Now W is equal to integration F dot ds. Now in a rotational motion W equal to integration tau dot d theta. D theta is the angular displacement. D theta is angular displacement. Now mechanical power P equal to F dot V. In a rotational motion, mechanical power torque into dW. Here F equal to dP by dt. Here torque equal to dL by dt. Couple. A special combination of force even when the entire body is free to move can rotate it. This combination of force is called the couple. Vehicle, car, उसका जो हैंडल आता है, स्टीयरिंग आता है. In this case, we give a couple. तो a couple is defined. तो means हमें इसे रोटेशन करना है, तो यहाँ पर हम फोर्स एक्टिंग परपेंडिकुलर लेते हैं. परपेंडिकुलर है ये भी परपेंडिकुलर बट आउटवर्ड. आउटवर्ड दिस इज इनवर्ड. तो magnitude of two forces same but in opposite direction. But force acting on a body is the line of force does not same. Okay, opposite है force or equal magnitude है, or force a line of force acting is always different. Means torque occurs. The couple is defined the combination of two equal but oppositely direct force, not acting along the same line. The effect of couple is known by its moment of couple or a torque by a couple. The torque is equal to R cross F. Here, torque equal to RF sin theta. That means F into R sin theta. Here R is the perpendicular distance between two coupling force, two couple force. So this is the R sin theta. Here we take. Generally, both couple and torque carry equal meaning. The basic difference between torque and couple is the fact that in a case of couple, both the forces are extremely applied, while in the case of torque, one force is extremely applied. In couple, two force, and in a torque case, one force, and the other is reactional. Work done by the torque is twisting the wire, means double equal to 1 upon root kx square, same like a spring. Okay, so this is the constant twisting coefficient of a couple per unit twist, C, and x is in a spring linear displacement. Here rotational displacement means angular displacement. So theta, the 1 upon 2 c theta square, but torque equal to c theta. So here we write force equal to F into x. Here we write torque equal to c theta. K into x, sorry. Now we take in equilibrium. Translational and rotational equilibrium. So here, force are equal and act along the same line. Same line. Means translational equilibrium, also rotational equilibrium. Because resultant force is zero. Force zero, the torque B or force acting on a same line means R zero. So torque P zero, FB zero. The body will remain stationary if initially it was at rest. Second, force are equal and does not act along the same line. This force की line ये है, this force की line ये. So resultant force zero means translational equilibrium, but perpendicular distance between two force, hey, not zero. It means summation torque not zero. It means rotational. Move in a rotational means it's spinning. So yeah. Force are unequal and act along the same line. Unequal. Force unequal है तो summation F not zero. And same line है R zero है तो torque equal to zero. So it move in a translational motion means slipping, not sliding. Sorry, this is slipping or skidding, not rotational motion. Force are unequal and does not act along the same line. Unequal. So summation F not equal to zero, summation tau not equal to zero. So rotational and translation both means is that rolling. तो नीट में ये भी करना है क्योंकि इससे इजी क्वेश्चन भी आते हैं. नेक्स्ट example, force given, force equal to 2i cap minus 4j cap 2k cap. X at point 3i cap plus 2j cap minus 4k cap. Position vector given r equal to 3i cap plus 2j cap minus 4k. The magnitude of torque. Torque equal to r cross f, I, j, k, 3, 2 minus 4. 3, 2 minus 4. F, 2 minus 4, 2. 2 minus 4, 2. So 2 into 2, 4. Minus minus plus. ये दोनों का मल्टीप्लीकेशन माइनस इस दोनों का मल्टीप्लीकेशन, तो 4 minus 16 मीन्स minus 12 आएगी. माइनस जे के 3 into 6 माइनस माइनस प्लस होगा प्लस 8, 4 into 2 8, तो minus 14 जे के 3 into 4 minus 12 minus 4, तो minus 16 के. So now magnitude of torque equal to square root of square of its component, addition of square of its component. So minus 12 square plus minus 14 square plus minus 16 square. The answer 24.4 हमें मिलता है. The answer is B. Next. The resultant of the system in a figure is a force of 8 Newton. Compare to the given force through R. The value of PR equal to PR equal to. So here force apply. तो वेल इक्विलिब्रियम के लिए हम इक्विलिब्रियम के लिए पीआर की वैल्यू क्या होनी चाहिए. ओके, तो हियर वी टेक मोमेंट ऑफ force means rotational equilibrium. So here we take 5 into PR is equal to, here we take 3 into QR. So RQ. So PR is equal to 3 by 5 QR, yeah, RQ. The answer is given in the form of RQ and PR. Okay, so 3 by 5. तो हमारा आंसर आएगा C. Rotational equilibrium retail. इक्वेशन एग्जाम में आ गया है जी में, तो हमें करना है. A horizontal heavy uniform bar of weight W is supported at its end by a two man, A and B, two men, equal force given. At the instant, one of the men let go of his hand. A छोड़ देता है, A पकड़ता है. तो means this rod move in this time. The other feel the force on his hand change to. तो कितना फोर्स एक्सपीरियंस करेगा एफ की जगह पर एफ डैश, क्योंकि डाउनवर्ड डायरेक्शन में तो mg था, लेकिन ये रोटेशन करता है तो अपवर्ड डायरेक्शन में दूसरा फोर्स लगेगा, सूडो फोर्सेस. तो कितना फोर्स लगेगा, ऑपोजिट डायरेक्शन में है तो वेट डाउनवर्ड, ऑपोजिट डायरेक्शन में ए, तो हमें फाइंड करना है ए. फर्स्ट कंडीशन इन इक्विलिब्रियम, तो F plus F equal to mg. Upward force is equal to downward force. So F plus F upon mg. So F plus F2F is equal to mg. Is F equal to mg by 2. When one man withdraw the torque on the rod, the torque equal to I alpha. I equal to mg. Sorry, I alpha. But here torque equal to downward direction में mg. This length is L by 2. So torque equal to, so means L by 2 into mg because angle between them is 90. तो R की जगह पर L by 2 है और mg है. तो टॉर्क की फॉर्मूला आती है हमारे पास R क्रॉस F. RF sin 90, R की जगह पर L by 2, F equal to mg sin 90, sin 91, तो torque equal to mg L by 2. But F equal to ma है. M की जगह पर I लेंगे, A की जगह पर अल्फा लेंगे, तो torque equal to I alpha equal mg L by 2. But I is equal to हमने last time लिया था. This is the and is the rotational axis. तो एंड में से पास होती एक्सिस के रिगार्डिंग मोमेंट ऑफ इनर्शिया ml square by 3 है. Here we write I equal to ml square by 3 equal to alpha. L cancel, mm cancel. Alpha equal to 3 by 2 gl. This is the angular acceleration. But linear acceleration is equal to r alpha, a equal to r alpha. So r is equal to, here we write L by 2 and alpha is equal to 3g by 2l. The answer given, a is equal to 3g by 4. This is the linear acceleration. इसके डाउनवर्ड डायरेक्शन में फोर्स आता है mg, अपर डायरेक्शन में सूडो फोर्स मिलेगा ma. तो mg माइनस ma इज इक्वल टू टोटल रिजल्टेंट फोर्स mg माइनस ma. mg, here we write ma. So m a equal to 3g by 4, 3g by 4, तो means 3 mg by 4, तो mg by 4, तो means w by 4. वो इस पर फोर्स लगेगा. ओके, एफ डेस लास्ट जो फोर्स आएगा उसकी वैल्यू मिलेगी w by 4. एंगुलर मोमेंटम, जितनी भी एंगुलर क्वांटिटी है उसमें रोटेशनल एक्सिस के परपेंडिकुलर डिस्टेंस आएगा. तो यहाँ पर the turning moment of a particle about the axis of rotation is called angular moment of particle. Means the moment of linear momentum. Angular momentum also we call moment of linear momentum of a body with respect to any axis of rotation is known as angular momentum. If P is the linear momentum of particle and R its position vector from the point of rotation, then angular momentum, to L equal to R cross P, to L equal to RP sin phi. Okay, n cap is the plane perpendicular unit vector. The angular momentum is an axial vector. Torque is also axial vector. Is that always directly perpendicular to the plane of the rotation and along the axis of rotation. Its unit is kilogram meter square per second, या joule into second. Dimension formula m1 L2 T minus 1. It is similar to Planck constant. In a chemistry, we take a Planck constant. Its unit is joule into second. Coordinate, if r equal to x, y, z, p equal to px, py, pz, then we write in a vector form. L equal to r cross p I j k x, y, z, px, py, pz. Y pz minus z py, y pz minus z py ik. X pz minus z px minus x pz minus z px jk. X py minus y px, x py minus y px kk. As it is clear from the figure, the radial component moment, the transverse component moment P equal to P sin phi. So the magnitude of angular momentum L equal to RP sin phi. So means L equal to RP phi. In torque, also we perpendicular component. Here, angular momentum also we take perpendicular component. Same figure. In torque, here we take force, here we take linear momentum. The angular momentum is equal to position vector into transverse component of angular momentum. Instead, the radial component of linear momentum has no role to play in the angular momentum. Magnitude of angular momentum L equal to P into R sin phi equal to L P into D. So D equal to R sin phi. The angular momentum is equal to linear momentum into perpendicular distance of the line of action of force from the axis of rotation. Okay. Now, maximum and minimum angular momentum. So torque की जैसा ही maximum MVR. When sin phi equal to maximum, phi equal to 90 means V and R perpendicular to it. Then L is maximum minimum. Sin phi 0, phi equal to 0 over 180 means V and R is parallel or anti-parallel. Then linear momentum is, angular momentum is 0. A particle is translatory motion. Always have an angular momentum unless it is a point on the line of motion, because L equal to mvr sin phi, L greater than if phi not equal to 0 or 180. Okay. In case of circular motion, R cross P mvr sin phi. In a circular motion, R is perpendicular to V and V equal to R omega. We take here sin 90 mvr, V equal to R omega, mr square omega. Is this is here we take I, moment of inertia, L equal to I omega. In linear motion, P equal to we take M into V. M की जगह पर I, V की जगह पर यहाँ omega. Now differentiate with respect to time. So dl by dt equal to I common d omega by dt equal to d omega by dt equal to alpha. So I into alpha. So dl by dt I alpha equal to, here we take tau. आगे के सब में हमने लिया था टॉर्क इक्वल टू आई अल्फा. तो dl by dt इक्वल टू टॉर्क. ओके, बट वहां पे हम लेते थे dp by dt इज इक्वल टू एफ. एफ की जगह पर यह टॉर्क और p की जगह पर यह l. So means here the rate of change of angular momentum is equal to the net torque acting on the particle. Rotational analog of Newton's second law. Okay. If a large torque act on a particle for a small time, then angular impulse of torque is given by. So J is equal to integration torque dt. So tau average T1 T2 dt. The angular impulse J equal to tau average delta T, means here we take delta L. So वहां पर P delta P equal to we take F delta T. Here we take delta P की जगह पर delta L, F की जगह पर tau और delta D तो है. तो means angular impulse is equal to change in angular momentum. The angular momentum of a system of particle is equal to the vector sum of angular momentum of each particle, means resultant angular momentum L equal to L1 plus L2 plus up to Ln. In a Bohr's hypothesis in a chemistry और फिजिक्स में भी आएगा, तो कोई भी इलेक्ट्रॉन है इसकी nth ऑर्बिट का एंगुलर मोमेंटम L इक्वल टू NH अपॉन 2 पाई गिवन अ बोर्स। तो हमें ये याद रखना है, केमिस्ट्री में आ गया और फिजिक्स में भी आएगा। लॉ ऑफ कंजर्वेशन ऑफ एंगुलर मोमेंटम। तो हियर टॉर्क इक्वल dl by dt. If net external torque we take a 0, means dl by dt 0, means L is equal to constant. L is equal to in a system L1 plus L2 plus up to Ln. So here we L equal to L1 plus L2 plus Ln is equal to 0. So means angular momentum of the system may be particle or body remain constant if resultant torque acting on it is 0. Means L equal to I omega. So torque equal to 0, I omega constant, means I proportional to 1 upon omega. Means angular momentum I omega remain constant. So when I decrease, omega increase. I increase, omega decrease. Okay? तो ये हमें याद रखना है। और ये सब एग्जाम्पल भी दिए गए हैं, लेकिन टाइम ओवर है, तो हम कल मॉर्निंग में लेक्चर लेंगे 6:45। ओके, तो यहाँ से हम स्टार्ट करेंगे। टॉर्क और एंगुलर मोमेंटम खत्म हो गया, अब उसके सम लेने हैं। तो टुमारो आई विल टेक 6:45।
Yes, sir.